Hello everybody, welcome to another lesson. So today we are going to talk about the area of squares, rectangles, triangles, parallelograms, and trapezoids. So first we have our basic square. If we remember right, we have a square where in a square all four sides are congruent to each other. To find the area of a square, you just take a side times a side, or in other words, you just take one side, set it equal to the second power. That's all you got to do. In a square, since all four sides are congruent, you just take one side, set it equal to the second power. So, for example, let's say you have a side of a square that is 4 centimeters. You want to find the area. So the area would equal that side of 4 centimeters raised to the second power. Well, 4 to the second power, that's 16. Centimeters to the second power, that's centimeters squared. So the area of the square is going to be 16 centimeters squared. That's exactly what you would get. So it's just taking a side squared. We'll do one more example. Let's say it's 25 inches. So we have a side of a square that is 25 inches. Well, again, to find the area, you'll just take that 25 inches and you'll raise that to the second power. Well, 25 to the second power is 625. Inches to the second power is just that, inches squared, or square inches, however you want to call it. So the area would be 625 square inches. So squares are easy. Since all four sides are congruent, you just take one side, set it equal to the second power. Alright, I think squares are pretty self-explanatory here, so let's move on to rectangles. So let's do a rectangle. Alright. Let me draw a nice rectangle here. It's a little crooked, isn't it? Again, in case y'all haven't figured out yet, I'm not Bob Ross. So alright, so we have a rectangle. You have your length of the rectangle, you have your width. In a rectangle, both pairs of opposite sides are congruent. This up top would also be the length, to the left would also be the width. What you do to find the area of a rectangle is quite simple. Area of a rectangle is nothing more than length times the width. It's just length times width. That's all a rectangle is for the area. So let's do a couple examples with a rectangle. Let's say you have 20 feet for the length, 12 feet for the width. Well, to find the area, you're going to take that length, in this case being 20 feet. Then you're going to take that times the width of 12 feet. Well, we do the multiplication. 20 times 12, that's 240. Then you have feet times feet, which would be feet squared, or square feet, however you want to call it. So the area of this particular rectangle is 240 square feet, because you just take the length times the width. Let's do one more example with a rectangle, because I think rectangles are also pretty self-explanatory. Let's say you have 17 yards, and then you have 5 yards for the width. So 17 yards for the length, 5 yards for the width. Well, again, To get the area, you'll multiply your length of 17 yards times your width of 5 yards. Okay? So then you'll just, of course, do your multiplication. 17 times 5, well, that's 85. Yards times yards, that's yards squared or square yards, however you'd like to refer to that. So the area of this rectangle is 85 square yards. It's just the length times the width. Very simple. Alright. Let's get into triangles. Let's deal with triangles. Triangles, the area formula is very simple. For the area, you're going to take half of the base times the height. You take half the length of the base times the height for the area of a triangle. Let's start out with the simplest type here, a right triangle. Alright, well that's alright. Okay. So let's see. A right triangle, the side that's standing straight up, you know, on the left that forms the right angle, the side that stands straight up, that could be your height. That could definitely be your height. The side that runs along the bottom's the base. So you would take half of the length of the base times the height in order to get the area of the triangle. In a right triangle, well, in any triangle, that's the formula, but in a non-right triangle, it's a little bit different to find the area. We'll go into that in a minute. But let's say you have your base being 4 inches, you have your height being 8 inches. So you want to find the area of this triangle. You're going to take 1/2 of that base of 4 inches times your height of 8 inches, which we know half of 4 inches, that's 2 inches. You would end up with 2 inches times 8 inches. So then you just multiply 2 times 8, you'll get 16. Inches times inches, that's inches squared, square inches, however you want to call it. So the area of this triangle is going to be 16 square inches. Let's do one more with a right triangle. And then we're going to do acute and obtuse triangles. We'll deal with those. Let's say this is 30 feet. So the base is 30 feet. The height would be 40 feet. So you have a triangle with a base of 30 feet and a height of 40 feet. Well, you want to find the area. Again, you'll just take 1/2 times the length of your base, which is 30 feet. And then you'll multiply that by your height of 40 feet. Well, we know that half of 30 is 15, so that would become 15 feet times 40 feet. Okay, so then we just do the multiplication. 15 times 40, that's going to be 600. Feet times feet, that's feet squared, or square feet, however you like to say that. So the area of this triangle is 600 square feet. Alright. So we've seen it with right triangles. Right triangles, they're pretty easy. The side that stands straight up is your height. That's pretty easy. Well, what about in an acute or obtuse triangle? What are we going to do with those? How do we find the area of those? Okay, no big deal. it's the area is half the base times the height. However, we don't have anything that looks like could be the height. You got your base, that's plain to see, but your heights, well, you got two slanted sides, those can't be your height. The height has to stand straight up. So, what you'll often see is your base. We'll say this is 8 meters for your base. Then often you'll see an imaginary line drawn from the top point of the triangle down to the base. From the vertex, the top point, you'll see an imaginary line drawn. That'll be the height. We'll say that's 5 meters. Okay? So, the height has to always stand straight up. It can't be slanted. So, it is normal from the top point of the triangle down to the base to see an imaginary line drawn to represent the height. That usually happens in acute and obtuse triangles. So let's go ahead, let's find the area of this triangle. Area still is half of the length of the base. The length of the base, that's 8 meters. Times your height of 5 meters. Well, let's do the math. Half of 8, that's 4 meters. So you'll end up having 4 meters times the height of 5 meters, okay? So 4 times 5, that equals 20. Meters times meters, that's meters squared. Or square meters, however you like to say it. The area of this triangle is 20 square meters. So, let's do another acute triangle here. We have our height. So again, I cannot emphasize this enough, the height has to be a straight line. It'll go from the top point of the triangle down to the base of the triangle. That's why right triangles are easy. You have the height as one of your sides, but when you get into acute and obtuse triangles, you have to have an imaginary line that gives the height. Okay. Let's say the height is 13 millimeters. The base is going to be 20 millimeters. Alright, so we have a triangle with the base length of 20 millimeters and a height of 13 millimeters. Well, still the area formula is the same. You're just going to take half the length of your base, which is 20 millimeters, times your height of 13 millimeters. Well, we know that half of 20, that's 10. So you get 10 millimeters times 13 millimeters. Well, 10 times 13, that's equal to 130. Millimeters times millimeters, that's millimeters squared or square millimeters, however you prefer to say it. But the area of this triangle is 130 square millimeters, based on the work we've done with the area being half the base times the height. Let's rock out an obtuse triangle while we're at it too, so I can show you what you're looking for in an obtuse triangle. That wasn't the straightest now, was it? The idea is to make this straight. There we go. Alright. Well, we have an obtuse triangle. None of these sides could be the height. We can clearly see the base because it lays straight down. We can clearly see the base that lays straight down. But the height in obtuse triangles, you often actually have to draw from the top point to where it would meet the base on the outside. And you kind of draw a line over. You draw an imaginary line over to kind of meet where the base would be. That's how you get the height. It almost looks like another triangle, an imaginary triangle, but you're just trying to find the height. So this imaginary line here would be the height. Because again, the height always has to be straight. It can't be a slanted side and be the height. It's got to be straight. So in an obtuse triangle, you'll start from the top point outside the triangle and draw down to where it would meet the base. Draw down to where it meet the base. You kind of extend the base out a bit, and then you start at the top point of the triangle, draw an imaginary line down to where it meets the other imaginary line from the base. So, formula is still the same though. Still the same formula no matter what type of triangle you have. We're going to say the base here. Now when you do the area of the triangle, you're still only considering the base of the actual triangle. So let's say it is 6. Yeah, we'll do 6 yards. The height is 5 yards. Okay, so again, we want to find the area of this triangle. You'll still take half of that base length, which is 6 yards, times that height, which is 5 yards. Well, we know half of 6 is what? That's 3. That'd be 3 yards times the height of 5 yards. So 3 times 5 is 15. Yards times yards, that's yards squared or square yards, however you like to word it. So the area of this triangle is 15 square yards. So again, if it's an acute or obtuse triangle, the height has to be a straight line. What I did for the obtuse is I extended the base out a bit, okay? I just kind of drew an imaginary line to extend the base out. Then I started from the top vertex of the triangle, drew an imaginary line down to where it meets the imaginary baseline, and that's my height. So that's how you do it in obtuse triangles. But I think we've seen enough triangles. Let's go ahead and do parallelograms. Let's do some parallelograms. Parallelogram. Find the area of one of those. Alright. So the area of a parallelogram is just the base times the height. So yes, a parallelogram is just the base times the height. Alright, so there's our wonderful parallelogram here. So the base is pretty simple. We see what the base is. That's your base. Now, the problem is with the height, though, your two left and right sides, those are slanted. Those can't possibly be the height because they're slanted. You can draw an imaginary line straight down anywhere from the top line to the bottom line, and that'll be your height. If you draw a straight line from the top to the bottom down, that'll be your height. You'll see the height like that. You might see it from the vertex. You might see it from the top vertex too, like this. You might see the height like that, or you might even see it outside the parallelogram, kind of like what we did with the triangle. You might see the height this way too. Either of those three ways are fine to list the height of a parallelogram, to give the height of a parallelogram. You may see it off to the side inside of the triangle. You may see it where this side meets the top, where the left meets the top at that vertex, at that edge. It'll start from there, come down to the base. You may see it right in the middle, a straight line from top to bottom. This is actually the same as that. It's just where it all starts on this line. Or you may see it even outside the parallelogram. You may see the height. Those are ways you could possibly see it. But I'm going to go with the simplest one for today. I will go with the simplest height, which will be in the middle. Either way, as long as you have your height, you got it. So, let's say I have a height of 20 inches. I have a base of 35 inches. So my height's 20 inches, my base is 35 inches. To find the area of the parallelogram, I just take my base, which will be that 35 inches, times my height of 20 inches. Which we know 35 times 20, that's going to be 700. Inches times inches, that's inches squared or square inches. So the area of this parallelogram would be 700 square inches. We'll do another example here or two with parallelograms. Okay, what about 39 centimeters yeah, 39 centimeters times 53 centimeters. All right. So this parallelogram has a base of 53 centimeters and a height of 39 centimeters. So you just define the area, you take the length of your base, that 53 centimeters, multiply it by your height of 39 centimeters, and then you just do the 53 times 39, which I don't know off the top of my head, so I'm about to actually go on ahead and do that multiplication in my calculator. It would give me 2,067. So I get 2,067, then centimeters times centimeters, that's centimeters squared or square centimeters. However you prefer to look at that. But the area of this parallelogram is 2,067 square centimeters. Alright, so parallelograms just base times the height. Pretty easy, right? Let's go into trapezoids. Let's go into our final topic of this lesson. Trapezoids. Let's do a trapezoid. Alright, this one's a bit of a doozy. The area of a trapezoid is equal to half the sum of the two bases times the height. So an area of a trapezoid is equal to half the sum of the two bases times the height. So let me draw a trapezoid here. Alright, we got our nice trapezoid. So notice, remember, a trapezoid has two bases. It has the top one and the bottom one. They're both parallel to each other, but they don't have the same lengths. Trapezoids are unique that way. We're going to call this top one base 1. We'll call this bottom base base 2. Alright, so we've established base 1 and base 2. Now we need to establish the height. Much like in a triangle or a parallelogram, the height has to, again, be straight up or down. These sides can't be your height because they're slanted. It's got to be straight up or down. So let's go ahead. Let's draw a straight line. You can pick anywhere on this top line, whether at the edge, this edge, or in the middle, to draw your height. I'm going to draw it in the middle. You may also see it again start at the left vertex and at the top vertex come down. You may also see it at the right vertex at the top and come down to the base. Either of these three are the exact same thing. Those are your height. Those are your heights. It really doesn't matter where the height's placed as long as it leads from the top line to the bottom line in a straight line. That's what makes up a height. So, alright, I think we're ready for some examples of a trapezoid. How to find the area of one. So let's say this one here is the top base is going to be 13 feet. The bottom base is 21 feet. Then let's say the height is 10 feet. Okay, so we have a trapezoid where the first base, which is the top base, has a length of 13 feet. The bottom base, base 2, has a length of 21 feet. And the height of the trapezoid is 10 feet. So let's go ahead and let's find the area. You'll take the area equal to half. So you do 1/2 times the sum of the two bases, which would be 13 feet plus 21 feet. All that times the 10 feet. Okay. Well, order of operations states we work inside the parentheses first. So you'll still have 1/2 on the outside. Now in parentheses, the 13 plus the 21, that's equal to 34. You would get 34 feet. All that times the 10 feet for your height. Well, now we know that half of 34, that's going to be 17 feet. So you would get 17 feet times 10 feet. Well, 17 times 10, that's 170. Feet times feet, that's feet squared or square feet. However you'd like to list it. So the area of this trapezoid is 170 square feet. And I'll do another example. Or I'll probably do 2 more examples since it's a trapezoid. Trapezoids can be a bit of a doozy because you have 2 bases and 1 height. Alright, so let's say this is 15 centimeters for the top base, 25 centimeters for the bottom base, and let's say you have 12 centimeters for the height. Alright, so we have a trapezoid. First base length is 15 centimeters. The second base length is 25 centimeters. The height's 12 centimeters. So once again, we're going to take our area formula, plug this in. You have half times the sum of your 2 bases being 15 centimeters plus 25 centimeters. All that times that height of 12 centimeters. Okay, well, again, order of operations dictates we do the parentheses first. So we'll leave that 1/2 alone on the outside for now. 15 plus 25, that's 40. You get 40 centimeters. then all that times that height of 12 centimeters. Now this is starting to come together. We know half of 40 centimeters, that's going to be 20 centimeters. So you'll have 20 centimeters times 12 centimeters. Well, 20 times 12, that's going to be 240. Centimeters times centimeters, that's just square centimeters, or centimeters squared, however you'd like to say that. So the area of this trapezoid is 240 square centimeters. And I suppose we'll do one more, because trapezoids, as I said, can get a bit funky. Of all the ones we've done today, I think trapezoids are probably the hardest, because you have two bases you got to consider. And you're dealing with order of operations and all that, so trapezoids to me are the hardest. Okay. Let's see. We got 37 millimeters. Then we have 63 millimeters for the second base. The height would be 25 millimeters. Okay. So we have a trapezoid where the first base length is 37 millimeters, the second base length is 63 millimeters, and the height is 25 millimeters. So again, let's plug this into our formula here for the area of a trapezoid. It's going to be 1/2 times the sum of the two bases, that 37 millimeters plus the 63 millimeters, all times the height of 25 millimeters. Alright, so order of operations dictates, again, we do the parentheses first, so leave that 1/2 alone for a minute. Take that times the quantity of 37 plus 63 inside the parentheses, that's 100 millimeters. That'd be 100 millimeters. All times the height of 25 millimeters. Okay. Now, we can do half of 100. Well, that's 50. That'd be 50 millimeters times your height of 25 millimeters. Now we just need to do 50 times 25, which would be 1,250, or 1,250, however you'd like to say that. And then millimeters times millimeters, that's millimeters squared, or square millimeters, however you prefer to say that. So, area of this trapezoid is 1,250 square millimeters. So today, let's go backwards. Trapezoid, probably the hardest because you got two bases. To find the area of your trapezoid, you take 1/2 of the quantity of the sum of your two bases times the height. Just like we did these examples here. And then, let's see, or another way to think of the trapezoid, add up the sum of your two bases, then you multiply it by 1/2, and then you multiply it by your height. That's a way you can do it. It's just however works for you. Parallelograms, you just take the base times the height, but remember, with the trapezoid or parallelogram, your height has to be a straight line from the top to the bottom. It can't be a slanted line. It's got to come from the top base to the bottom base. That's how you get your height. It can't be the slanted lines. Triangles, right triangles were easy because in order to do your triangles, you need to have a height again. It's got to be a straight line. Your right triangles, the one side is a straight line going up and down, so that is your height. But the area of a triangle is half the base times the height. And then, of course, rectangles were easy because it's just length times width. Squares were easy, it's just a side square, just the side of the second power. So that's it for these shapes. Tomorrow next lesson we're going to do circles, the circumference and the area of circles. So I hope everybody has a good night. Take care.